Today we are going to learn something very interesting, that why does the sum of digits of any multiple of 9 is also a multiple of 9, or vice versa, why the number whose sum of digits is divisible by 9 is also divisible by 9. Suppose we have a number 99. If we add its digits, that is 9 plus 9, so it gives 18, which is also a multiple of 9. So similarly, you might have learned this in your school, that for as the divisibility rule of 9, that the sum of the digits of 9 is also divisible by 9. Today we are going to prove it. So let's say we have a number. I'm going to write its digits as x1, x2, or in the other way, from right to left, x1, x2, x3, so on till xn. Okay, now I could write this as x1 into 1 plus x2 is in 10th place, so x2 into 10, x3 is 100th place, so x3 into 100, and so on. Okay, so now I can expand this as x1 plus x2 into 1 plus 9, expand this as x3, 1 plus 99, and so on. Now I can open the bracket. This is x1 plus x2 plus 9x2 plus x3 plus 99x3. Similarly, if we'll obtain the next terms, it will be x4 plus 999x4, and so on. Now we can group the same terms together. We can group x1, x2, x3, x4 together, and then all the 9 terms together. So this is x1 plus x2 plus x3 plus x4 plus 9x2 plus 99x3 plus 999x4, and so on. Okay, so now this is nothing but the sum of digits, if you agree, right? This is just the sum of digits. So let's write sum of digits as s. This is sum of digits. Okay, I'm sorry. So sum of digits plus, we can take 9 common here, so 9 x2 plus x3 x2 plus 11 x3, my bad, plus 111 x4, and so on. Okay, so this was actually equals to the our number, which was x. Okay, now x minus s equals to 9 into x2 plus 11 x3 plus 111 x4, and so on. So you can clearly see that x minus s is a multiple of 9, right? This is in multiplication, so x minus s is a multiple of 9. So that means 9 divides x minus s. Okay, if 9 divides x minus s, that means we can prove this by contradiction. If x is a multiple of 9, let's say x, case 1, x is a multiple of 9. So if x is a multiple of 9, then 9 divides x and 9 divides x minus s. So we can if 9 divides x and 9 divides x minus s, then we can add them, and 9 will divide their addition, that is x plus x minus s, and 9 will also divide their subtraction, so x minus s. So if we open this term up, the subtraction one, this one, 9 divides, so x minus x is 0 and we have s remaining, so 9 divides s as well, right? So we can see that if x is a multiple of 9, then the sum of digits is also a multiple of 9, right? We prove this. Or case 2, if x is not a multiple of 9, if s is a multiple of 9, s is sum of digits by the way, multiple of 9, so x minus s equals to 9 into something, my god, sorry, this is not x minus 9, this is x minus s equals to 9 into x2 plus 11 x3, something like this. Okay, so 9 divides x minus s. This symbols represent division by the way. The left portion divides the right portion. Okay, so 9 divides x minus s, and 9 divides s. So 9 and will also divides their addition. So 9 divides x minus s plus s. S and s, this is 0, and 9 divides x as well. So we prove this by contradiction that if s is a multiple of 9, then if sum of digits is a multiple of 9, then the original number is also a multiple of 9, or if the original number is a multiple of 9, then the sum of digits is also a multiple of 9. We can prove this by contradiction. I hope you understood the proof. This was actually very intuitive, very easy to prove. Nothing too mathy. I think this was clear. If you have any doubts, you can comment in the comment section. I'm more than happy to help. Thank you.